So it's starting, there we go. Okay, so for this one, for the prep, I feel like there's just a lot of putting numbers in the applet, and we can do them all together. Did anyone have questions on doing them? Or do we want to do a couple of them together before we do the quiz? How's everyone feeling confident-wise?
I'm feeling good.
Yeah, I didn't have any questions.
I think we could jump into the quiz, and then whenever the issues come up, then we could work through them.
Okay, I kind of feel the same way. I was like, well, someone's got to know why I get this weird -4 with an E, whatever that means. So, okay, yeah, but otherwise I felt pretty good about my math. So, okay, I'm going to get my quiz up, the correct quiz this time. Okay, lesson 7, group quiz. Okay, group meeting quiz. Sorry, my computer just is slow. Okay, here we go. Okay, so starting with question 3, use the normal probability applet to find a combined area under the standard normal curve that is right of z 1.385 and to the left. Round our answer 3 spaces. Okay, so 1.358.
I got 0.175.
Yep, that's what I'm getting.
That's what I have as well. Okay, did anyone have questions on how any of us did that before we move on, just assuming we all know? Just got on the applet? Okay, great. Does someone want to read 4?
Oh, I can read that. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Okay.
It'll be the distribution of the sample means, because you have to take the standard deviation and then divide it by the square root.
Right.
The 9 observations. So.
Oh, I see. Okay, I was like, wait, the means will be the same, but it's asking about the standard deviation.
Yeah.
Okay, so it'll be B, the distribution of the sample means.
Mm-hmm.
All right. Anyone want to read 5?
Which of the following results implies that the spread in X decreases as the sample size increases?
Results. I think it's the normal distribution, right?
I think that's the law of large numbers.
Yeah, I was going to say.
I think so too.
Law of large numbers.
So that the spread in X decreases. So the more samples you get, the closer and closer you get to the normal, right? The spread down.
Oh, okay. All right. I see what you're saying. I'm trying to just picture it on a graph, but yes, that theory does state that as you get a larger sample, then everything's going to get closer to that mean.
So the law of large numbers, it refers to the spread, and the central limit theorem is like the way it's distributed, right? The shape.
Right.
Jacob, is your baby awake? I hear crying.
Yeah, he's awake. He hasn't been feeling very good, but he hasn't been asleep for very long.
Oh.
God. I got
So
my
maybe we can.
My mom radar's going, oh, somebody get the baby.
I know. So hopefully we can get this through quick so we can get to him.
Okay, so then we're given some information. And so for question 6, Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding with her score?
So we have to take 160 minus 150.8, right?
And then divided by 8.8, right?
Yeah. because that's just one.
Right.
We're talking about not about a sample, but we're just talking about one person.
I'm getting 1.045.
Yeah.
Sorry.
1.045.
Okay. Good.
Okay.
Sorry,
What
what did you get again?
I got 0.932.
And what did you get, Jalen?
I got 1.045.
That's what I got as well.
Let me do it again really
Yep.
quick.
So I took the 160 and I subtracted the mean of 150.8, and then I divided that by 8.8 as the standard deviation to get her z-score, and I got the 1.045.
Yeah.
Who was it that got the 98? What formula did you use?
Oh, just kidding. Okay, that's what I got too.
Oh, okay. All right. As long as we're all on the
did
same
my
page.
math wrong.
Nope,
Okay.
that's why we do it as a group. Okay. Does someone want to read 7?
Yeah, I'll be right back. Hold on.
Sure.
Oh, good. I was like, I can't think. I'll hold them. Get him over.
Should we wait or shall we continue and then catch him up?
Let's go.
Okay.
If you want, you can actually mute him if it gets loud.
Oh, I don't know how to do that.
In your meeting controls that come up on the side, there's a button called Control Room. So it's the button under Q&A.
The control room? Is that what you're saying? Says there's an error when I try that. I'm not going to mess with it. I don't want to ruin our recording.
No worries. Hi.
Poor guy. Okay, well, let's continue on and
You know what? Maybe.
okay.
Do you want to just mute your mic, Jacob?
Yeah, sorry.
Nope, you're just fine. Thank you.
We'll just all keep going. It's no problem. We'll keep going, and you can listen.
How do I mute it?
You guys, you can multitask. So if you go up to the top, there, yeah, you got it. There you go.
Okay.
Okay, great. Okay, so then for question 7, what is the probability that a randomly selected student will score above 160 on the quantitative portion of GRE? So,
We got to use the applet on this one.
yeah, and we just type in the 1.045, right? Because that's the number we just figured out, right?
Yeah.
You know, are we writing it as a decimal or as a percent? Decimal.
Decimal, yeah.
Okay, so I'm putting 0.296. Is that what you guys have?
I'm getting
Oh.
0.148.
Yeah, nope, I have both greater and smaller. Yes, 0.148.
Okay. Is that what everybody else is getting to?
Let me see. I put the wrong. Oh, I put the wrong number in the applet.
Yeah, so we have a z-score of 1.045, and we're looking for anybody that's greater as our probability.
Sorry, I'm just behind here. Okay, so
No,
what
you're just fine.
the probability that a random student will score above 160? And we had
Yep.
a positive. Oh, we had a positive z-score. Okay,
Yeah.
Yep.
you got 0.153.
No, I got 0.148.
Yeah, 148.
I see it now. Got it.
Did you get
Okay.
that?
Yeah. 0.148.
Okay. All right, does everyone feel good about that? We're ready to move on to the next one?
Yes.
Okay, perfect. Okay, let's see. Question 8. Does someone want to read 8?
Sure. A random sample of 5 students was selected to take the GRE, and their scores are what is the z-score corresponding to the sample mean of these students' scores? So first we have to add all these up, right, and divide by 5.
Yep, to find the mean. 60.
I'm getting a mean of 159.8. Is that what you guys got?
I got 160.
Yeah, I'm just getting 162.
I got 160 as well.
Okay. Yeah, that's what I got too. Okay.
Okay.
So 160.
Then for this one, we have to do the square root, right?
Yeah.
To find the z-score.
Okay, wait, what are we doing?
So for this
Because
one,
we don't know the standard deviation, is that
No.
right? Or,
No,
Yeah.
it wouldn't be the square root one because it's one sample.
So
We're down to mean for one sample. It's not different samples because those 5 scores are 5 individual students from one sample.
okay, yeah, that makes sense.
Okay.
But in order to find a z-score, okay.
we have to go back up to for the mean.
Yes, okay.
Right? 160 minus 150.8.
Isn't it the same?
Yeah, I'm like, aren't we getting the exact same thing?
I think isn't this with a sample? I think we do divide it by the sample size.
Yeah, I think so too. I think we divide it by 5
We take
because
8.8.
n equals 5.
Yeah.
Sample size of 5.
8.8 by the square root of 5. Is that what you guys are doing?
That's what I thought.
Yeah.
Okay.
That's 3.
Okay. Okay, so I'm getting a z-score of 2.338. Is that what? Anyone?
I got 2.571. Let me do it again.
I'll do mine again as well. So we're doing 160 minus the 150.8. And then we're dividing that by 8.8 divided by the square root of 5. Is that right?
Yeah.
Yeah, I still get 2.338.
Yeah, that's what I'm getting too.
Okay.
What were you getting?
We're getting 2.238.
I got 2.338.
2.338, sorry. That's
Okay.
what
Maybe I'm doing my math wrong again, but because I'm getting 152.336.
Jono, what did you get? Did you redo it or?
I got 2.338.
Okay. And then Daniel, I'm having a hard time hearing you.
Oh, sorry.
That's okay.
Yeah. So it's 160 minus 150.8.
0.8. That's going to be
divided
the
by-
top.
In my calculator, I have to put those in parentheses.
Yeah, I have to do all of it in parentheses. The top's in parentheses and the bottom's in parentheses.
Oh, okay. Let's try it that way then. So 160 minus all right, it's 160 minus, sorry,
No, you're just fine. So here's how I have it written in my calculator, Daniel. I've got parentheses 160 minus 150.8 end parentheses. And then I
Okay.
divide it and I start new parentheses for the bottom.
Mhm.
8.8 divided by the square root of 5 end parentheses.
Okay. That time I got the 2.337.
Okay, great. And I rounded mine up and put 2.338.
Yeah, that's what I did.
Yeah,
Since they want us
yeah.
to put it to 3. Okay, so we all feel pretty comfortable with that one before we move to 9.
Mhm.
Okay, would someone like to read 9?
I can read it.
Okay.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answer to 4 decimal places. Okay. So see, this is why I was saying in the last one we didn't do the sample one, because those scores are not sample scores. Those 5 scores are scores that 5 people, myself and the rest of you got on a test.
Well, that's considered the sample. So if I have 80 people that took a test and I'm choosing 5 of them, then my sample size is the 5. N equals 5.
You're
right?
That's your, but the mean of those 5 is your sample.
Oh, yes. Okay.
Because say we're in a class of what, 50 or so people. We all take the test and then they do random samples of the different people. So they pick the 5 of us out and do one mean, and then they go and they pick another 5 out and they do the mean for that 5.
Right.
And then they go and pick another 5. So those are the sample means. Whereas in the first question here, they are doing one sample. Does that make sense?
I think that we're looking at a sample from a larger group, and that is the definition of what a sample is using. I think we're supposed to divide it. So you're saying that we should not have divided by the square root of 5?
Square root of 5.
For the first one, but we should for the second one.
But for the second one, we should. So to get the z-score for the first one, you take the mean of the five numbers and divide it by the deviation. Just divide it by the deviation.
Okay, so I feel like we have a couple ways that we can do this because I feel like we're divided on it. So we can discuss the options, because I think I understand what you're coming from, and I understand definitely what the other side of that is too. And I think that they're both sound. I think it's just how we read the question. So then the question is, what's the proper way to read it? How should we be interpreting that? So we have a couple options. We can keep discussing it. We can all agree to try one way, and if we miss it, we have a second chance to take it, and then we can reinsert it as the other way. I mean, how do you guys want to proceed with? We usually are kind of all in agreement, but I mean, I think that both of those are pretty valid ways to look at this question.
Well, yeah. I'm just trying to see also if, and there's really no place where it talks about what the.
I think the way the question is worded is kind of confusing.
So so number 8, if we were to divide the 165 minus
Well, I think we could probably move on, Dan. And if you want to see if the answer, since there's 3 of us, I don't know, Jacob, do you want to unmute your mic? What did you think about this question? So.
Is it number 8? Is that what you're talking about?
Yeah.
yes.
So I think, just my personal opinion, I think that it is 2.338, and then I can submit mine, and if it's wrong, we can do it the other way.
That's a great idea.
Okay.
So if on the next question, we take 2.338 and plug that into the normal probability applet, right? To find out the probability of 5, so we'll have a mean score that is greater. So that one little sliver on the far right would be highlighted or shaded on the probability applet, and now I'm getting 0.0097.
That's what I'm getting.
And I got point.
We lost you. What did you say, Jacob? Oh, I think he's frozen. Okay, so moving on. Should we look at 10?
Okay, I have a quick question though. So I got 0.0. Okay, so we're doing it to 4. So 0.0097.
That's what I got.
Okay, I was like, how do we round that? But I guess it lets us do to 4 decimal places. So,
yeah, which is kind of a clue too that you're on the right trail. Is if it lines up like that, you're like, oh, okay. So I think we're doing good.
Yeah. Okay. Okay. All right. So I feel like we should move on just so that we aren't stuck on that one. But I feel like I want to make sure we're all okay with that and all okay to move on, because I'm not sure that Dan is totally in agreement with us, and I don't want him to feel like.
Oh no, it's fine.
Are you sure? I'm like, one of us will submit ours first to see, and if we were wrong, then you can re-explain it to us, and we can redo it the other way. Does that sound good?
Yeah, that's fine.
Okay. All right. As long as we're all in agreement to do that. Okay. Perfect. All right, so then we're on 10. Who wants to go for 10?
I can read that. So we're using the GPA of the BYU Idaho students.
Okay.
So it says, what is the shape of the sampling distribution if the random variable x bar, which represents the sample mean of the 81 students who are selected? So wouldn't it be approximately normal?
Yeah.
Yeah, I believe it's approximately normal because it's a larger random sample.
I agree.
So the next one is, what is the mean of the distribution of the sample means? So sampling distribution for all possible sample sizes of 80, or samples of size 81 that could be drawn from the parent population.
The mean would be the same as the overall mean, right?
Right, and that is, let's see, I'm trying to find
3.5.
The 3.5.
Okay.
Sorry, did you say 8.5?
Yeah, 3.5.
Oh, 3.5, okay.
And then what's the standard deviation of the distribution sample means? So
So that's going to be the 0.7 divided by the square root of 81, right?
Yep.
And I get 0.077778.
yeah,
So we're rounding this one to 3 decimal places.
Yes, 3 decimal places. So
0.078.
0.078. Everyone good so far?
0.78,
Okay.
right?
0.078, yes.
0.078, okay.
Okay, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3? Okay.
okay.
So we need to find a z-score and then plug it into the applet
Mm-hmm.
and shade the far left,
Mhm.
right? Okay.
Yes.
Yeah.
So
Okay.
3 minus 3.5 over 0.7 divided by the square root of 81.
Mhm.
Yes. I always forget all my parentheses and I have to redo it every time. Okay, so for my z-score, I'm getting a negative 0.0317.
I got negative 2.5714.
Okay, so I very well could have done that wrong.
Yeah, I'm getting a different one. Let me redo it.
Okay,
I got
so
negative
let's see.
2.5714 as well, but I'll do it again.
Okay, so we are
I
going
got
to,
the, I got the same as you.
what did you get?
Negative 2.571.
Okay. Now,
Okay.
yeah, now I'm getting that.
Okay, let me try this again. I'm not, okay. So 3.3 minus 3.5 divided by 0.7 divided by the square root of 81, right?
Yeah.
Oh, I did get it that. I don't know what I did differently that time, but I also got a negative 2.5714.
Yeah, that's what I'm getting.
Okay.
And for the answer, I got 0.005.
Yes,
Yep.
is what I get as well. Okay, so everyone got that? We all had different numbers for some reason. Does everyone have the same number? Are we all feeling good about it?
Yeah.
Did everybody guess?
Okay.
0.005, is that what you guys said?
Yeah, you feel good with that, Dan and Jano?
Sorry, what was it? Sorry, what was that? Sorry, what was that one? What was that again?
So we got for the z-score negative 2.571. And for the answer, it's asking what will the probability be less than? So we got 0.005 on our applet.
Okay. All on the same page.
Okay. All right. Someone read. I'll read 14. I'm already reading it. What is the probability that the GPA for 81 randomly selected students will be greater than 3.3?
So we just shade the middle and the far left, right?
Mm-hmm.
The middle and the far right,
Oh, far right, sorry.
right? Or I guess we could do 1 minus our previous answer would also be right.
True.
Okay, so I'm getting 0.9949, 0.995.
Mm-hmm.
Mm-hmm.
Okay, does someone want to, everyone good with that before we move on to the last one?
0.499, right?
Wait, what?
0.499?
5. Yeah,
Yeah.
0.9
0.995.
when we round it.
Okay.
Okay. Okay, does someone want to read the last one?
I'll read it.
Okay, thanks.
United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. So round your answer to 3 decimal places. And here's a note. As extreme or more extreme means that we are not only interested in the values that are lower than the ones we observed, but also the values that are as far away from the mean as ours is in the positive direction. So we find our z-score, plug it into the applet, and then shade both of those far
On the
left, far
outer
right.
side.
Mm-hmm.
Right?
Okay. Okay, so we are taking in this one 177.6 minus the 185,
Mm-hmm.
then dividing it by 26.7 divided by square root of 48. Is that correct? To get our z-score?
Mm-hmm.
Okay. Ah, the parentheses. They're killing me. Minus 185.
So I'm getting a z-score of negative 1.92.
Okay, that's what I'm getting as well. So then I'm getting a, because we're not doing the z-score right, we're doing the probability on both sides, the far left and far right. Okay, so I'm getting the probability area of 0.055.
That's what I'm getting.
Yeah.
Okay. Everyone good?
Yep. Do you want me to submit it?
Go ahead.
Sure.
Did Jacob say he was submitting it? He did, right? Oh, there you are.
In a second.
Oh,
Mine's
I'll submit mine too. I live dangerously like that.
submitting for.
You're so wild.
You got it, 100%.
Okay.
Okay, great.
All right, well, thank
Okay.
you so much.
Yeah.
Right now.
Okay, so we got ours submitted. I think your screen froze on us, so just so you know, we did get it submitted and it did come back at 100%. Did anyone have any questions on homework or how we did the quiz or anything before we go?
I didn't have any.
No,
Okay.
I don't have any.
Hey, I really appreciate you guys every week. I just have to like say that because it's a struggle. It's real for me. So I appreciate you guys like taking the time, helping me out. And I'll get this one posted as well soon. So okay. Thanks a lot, you guys. Okay, bye.
Next week,
Oh, who's doing next week?
Oh yeah, who wants?
I can go back to doing it if you want. Or Dan, do you want to do it? Or
I can. I can do it. Yeah, and I'll just post the link on the
On the
collaboration
discussion board?
on the discussion board. Yeah, about
Great.
15 or 20 minutes before.
super.
Perfect.
And if anything comes up, just shoot us an email. I don't check the discussion board until the morning of, but
Oh, you don't? I'm always nervous I'm going to miss discussion boards. I check them like way more often than I need to.
I'm not good at discussion boards.
I'm not